Hey everyone, welcome back to the Foundry by Forge College. So glad you're joining us. Okay, so in our previous module, we tackled this really crucial step of integrating TypeScript with Hardhat, right? We got all our environments talking, updated the configs, and finally proved that a simple compile run could actually finish without throwing those absolute nightmare type errors. But, well, before we start pouring the digital concrete and getting to the fun part of writing smart contracts, we actually need to conduct a thorough blueprint inspection. So think of today's explainer as our final site survey. We're going to lock down our foundation right now, just to make absolutely sure that when we do start building, the whole thing stands rock solid. Our main focus today? We're going to completely finalize our setup and prepare for writing smart contracts. All right, let's grab our literal or, figurative engineer's clipboard and quickly outline our agenda. Number 1, verifying your Hardhat setup. Number 2, scripting the readiness check. 3, the final configuration checklist. 4, producing the readiness report. And finally, number 5, signing off the blueprints. Let's get right into it. So, ready to write some smart contracts? I bet you're kind of hovering over your keyboard right now, super eager to write some solidity, but not so fast. Look, we've literally all been there, right? Experiencing the universal pain of spending, 3 entire days debugging this massive failure in our code base, only to realize later it was caused by something a 30-second setup check could have easily caught. So taking just a few minutes right now to finalize and validate the setup is going to save you hours, maybe even days of absolute frustration down the line. Section 1. Verifying your Hardhat setup. We're going to check those core configs first. We really need to look closely at the tools that form the absolute bedrock of our project before we start adding any actual weight to them. Now, before we get completely lost in the technical weeds, let's talk about the Hardhat runtime environment, or the HRE for short. You can kind of think of the HRE as the central engine of our project. It basically pulls in your config file and all those environment overlays on one side, and then it outputs your local networks and compiler settings on the other. So when we inspect this at runtime, we're essentially running a diagnostic check on the engine itself. We want to be 100% sure we aren't missing any critical local networks and that our Solidity compiler settings are exactly where we left them. Next up on our survey is TypeChain. So if the HRE is our engine, TypeChain acts as the wiring of the project. It generates these TypeScript bindings that allow our front end and our testing scripts to talk to our smart contracts safely. If its output directory is missing or even just misconfigured, well, that beautiful TypeScript setup we worked so hard on in the last lesson, it won't be fully operational, and that type safety we just achieved goes right out the window. To check all these systems, we're going to create a really small diagnostic script, and we'll call it checkSetup.ts. What this does is it automatically scans our networks, our compilers, the optimizers, and it verifies that the TypeChain directory is actually there. It gives us deterministic, machine-readable proof that things are working. So it's not just us crossing our fingers and guessing things are okay, it's the machine literally proving it to us. Okay, moving right along to Section 2, scripting the readiness check. Automating your checks is the goal here. We want to ensure our site survey is totally repeatable. Because, honestly, a test you only run once manually, that's just a test you'll eventually forget to run at all. We're going to script this in 4 super easy steps. First, we create a readiness file. Second, we import our file system and path modules. Third, we write a simple function to validate our configs and the TypeChain output. And finally, step 4, we establish an exit status. 0 means everything is perfect, and 2 means, hey, we have some missing items. By integrating this directly into our package manifest scripts, it guarantees a totally consistent development environment for literally everyone on your team. And this difference right here brilliantly illustrates a secure foundation versus a faulty one. A passing setup, it just hums along perfectly, outputs a clean code 0, and gets out of your way so you can work. But a failing setup throws a code 2, and it acts as this strict guard in our CI pipeline. It basically hits the big red button and stops the assembly line before a bad configuration can sneak in and ruin your smart contract compilation. Which brings us to Section 3, the final configuration checklist. We need some step-by-step validation here. We're establishing a repeatable workflow for our contracts, a checklist we can rely on and run through every single time without fail. So here is our 5-step checklist. Number 1, run those automated checks we just built. Number 2, manually inspect the compiler and optimizer settings, just to make absolutely sure they match the project requirements. Number 3, validate our TypeScript toolchain. We do this by running npx_tsc-no emit to catch any sneaky type errors. Number 4, confirm our development scripts actually work locally. And number 5, produce our readiness report. You know, this highly structured approach directly mirrors the rigorous step-by-step learning paths you'll find in the programs at Forge College. We truly believe that mastering the fundamentals right now prevents massive, massive headaches later on. Okay, Section 4, Producing the Readiness Report. Let's document your success and see exactly how this builds into our official inspection document, the setup_readiness markdown file. Now, what's really cool about this matrix is that it becomes your literal baseline blueprint. By mapping out the check, the command, the expected output, and the actual result all in a nice clean table, you completely isolate your variables. Because you have this documented baseline, if you run into compilation errors later on, you can instantly distinguish between pre-existing configuration issues and brand new errors introduced by the contracts you just wrote. It isolates the variables so you know exactly where to troubleshoot without losing your mind. And finally, Section 5, Signing off the blueprints. It's time to pour the concrete, folks. The foundation is officially set. Look, if you take away absolutely nothing else from today's explainer, please remember this golden rule. Setup verification should be automated and repeatable. Automation removes human error, and repetition ensures consistency. These scripts act as vigilant guards for all the upcoming activities we have in the Ethereum Dev Stacks and Frameworks track. You do the hard work of setting them up exactly once, and they protect your time and your energy forever. So, I want to leave you with this final thought. When, and I mean when, not if, when your very first smart contract compile fails, will your readiness baseline prove the code is at fault or the configuration? Well, thanks to the work we just did, you will know for sure that it's the code, which is going to save you endless hours of chasing ghosts in your config files. Please make absolutely sure you bring your setup_readiness document to our next lesson as we finally dive into writing those contracts. To explore more about this topic, get into some deeper resources, and master other amazing Web3 topics, I highly encourage you to visit our platform at forge.college. Keep building, keep verifying, and I will see you in the next one.